In this segment, we'll examine an example of a graph that shows how two different articulators might interact in different ways during the productions of different words, and you'll see how this kind of representation of speech movements can account for some commonly described phonological rules. In this example, Kent describes the phasing of the movements required for k and m. You can see how the articulators might move in different relationships to one another. In this diagram, we see the time course of movements of the back of the tongue for k here. But remember, in order to make a stop consonant, there's always something else that has to move, the velum. The velum is open at rest, remember, which means that to close the velum, the muscles of the soft palate have to contract. So down below the curve that shows the raising of the back of the tongue, then the point of maximum displacement of the tongue, in other words, when it makes contact with the soft palate, then the movement of the tongue back down to the floor of the mouth, there are two different time courses represented for the movement of the velum. The first is in a word like next, in which the velum is starting from an open position. Remember, the velum will be open for the n sound, and then it'll have to close at some point before the k stop closure is complete. The graph of movement pattern A shows that in the word next, the velum closes slightly before the back of the tongue makes contact with the soft palate. This makes perfect sense given what we know about the vowel in the word next. This vowel is not nasalized, so it's essential that the velum close during the vowel and not remain open until the final stop consonant is produced. This relative timing is different in a word like camping, where the k sound is the initial sound in the word. There's no vowel preceding the k sound, so it's not necessary for the velum to close before the stop consonant is produced, so it doesn't. Instead, the velar closure is coincident with the back of the tongue gesture. There's an important implication in these diagrams. The movement for k is not always the same. In some cases, what's required to produce k includes asynchronous closure of the velum, and in other cases what's required is synchronous movement of the two articulators. Below the dotted line is a representation of the nasal consonant m. Just as above, it's important to remember that velar movements must be considered in thinking about consonant articulation. And in this case, since the consonant is a nasal consonant, we know that the velum must be open during the nasal consonant production. So the direction of the velar movement is reversed compared with the movement represented above, since this is a gesture that involves opening the velum rather than closing it. The principle in reading the graph is the same, though. In all cases, an articulator's rest position is considered to be the lowest point on its tier, and the further an articulator moves away from this resting position, the higher the graph will go. So the lips, whose resting posture is closed, will start out open in a word like camping. The lips will be open into the vowel a, and they'll only start to move together as the speaker gets ready for the m sound. Notice what happens with the velum here. It lowers or opens before the lips come together. And what's happening right before the lips come together? The speaker's producing the vowel a. And if a speaker produces the vowel a while the velum is open, then some air is going to escape through the nasal cavity. The result is that such a vowel will be perceived as nasal. In essence, this is a physiological description of the linguistic phenomenon of vowel nasalization when a syllable contains a nasal consonant in syllable final position. It's all because of the velum opening just a little bit ahead of the oral closure for the nasal consonant. But the fun doesn't stop there, because you might notice that in trajectory A here, the velum moves back up. In other words, it closes again, while the lips are still closed. What's the result of this velar closure that happens while the lips are still creating a complete oral closure? The air has no route out, so air pressure inside the mouth starts to increase. Then when the lips do open up, right here, there's some air pressure built up that's released as a sudden burst. And with the nasal passage still completely closed off by the raised velum, the only place where that air pressure can be released is through the now open mouth. And what do we call a consonant that's produced with a brief period of closure in both oral passage and nasal passage, followed by an oral opening and the resultant burst of air as the increased oral air pressure is suddenly released? We call it a stop consonant. And guess what the sound right after is in the word camping? That's right, it's a stop. And because it's a stop that's homorganic with the preceding nasal, the oral articulator doesn't have to make a separate gesture. The lips just stay closed, and the nasal stop combination is created by the simple difference in relative opening and closure of the velum compared with the closing and opening of the lips. Finally, in this diagram we have movement pattern B for the velum shown. This is for the in a word like Monday. Here we see that the opening of the velum is coincident with the closure of the lips, which is how we usually think of a nasal consonant being produced. Just as with the k sound above, this shows that not all articulatory patterns for are the same. A speaker will routinely alter their movement patterns to fit the demands of their actual speaking task, rather than consistently producing the same movement pattern for each instance of a sound that our phonological system treats as the same. So this is a fairly straightforward diagram showing two articulators moving in relation to each other. In the next segment, we'll look at full gestural scores, which show the movement of all of the articulatory components.